Some tricks to help you get through some of these transformation problems. First thing I like to do is mark what the x and the y are for my coordinates. So here's the coordinate here, that's negative 6, 9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know it's right there. And then we're being asked to translate it left 4 units, down 1 unit. Left 4 units, 1, 2, 3, 4. So it's going to go that way to the left 4 units. And then it's going to go down 1 unit. And then it's down 1 unit. So this is the point, negative 6 comma 9. If I go to the left 4 units, left matches with the x. So that's a negative 4 on top of the negative 6, making negative 10, comma. Then the 9 is down 1 unit. Down is in the negative direction. Down from 9 goes to 8. So we're right here at the 8. Negative 10 comma 8. I like to do both. Do the verbal representation of how does it get represented on the graph. Left is adding negatives. Down is adding negatives. Negatives to the x, negatives to the y. So you can kind of also break these down. Sometimes they would write this same problem as negative 6, left 4, minus 4, 9, down 1, down 1. Negative 6 minus 4 is negative 10. 9 minus 1 is 8. So try to graphically, just kind of helps it make more sense. And then you can kind of jump straight into the algebra if you understand what left, down, right, and up mean. The next one, let's go ahead and look at 1, 6 reflected over the y-axis. So x is 1, y is 6, x is 1, y is 1, 2, 3, 4, 5, 6. There's our point at 1, 6. And then we're reflecting over the y-axis. The y-axis right here is our line of reflection. And it helps to know what the equation of a line of reflection is. It hits the x-axis at 0. So the y-axis is the same as x equals 0. I always like to say if there's only one letter, then it has to be a flat line. Flat up and down or flat left and right. And same thing, if you have a line left and right flat, it can only have one letter. If it goes up and down flat, it can only have one letter. And the trick is it has the letter of whatever it hits. So this hits x equals 0. That's why x equals 0 is the equation. Okay, so that's my reflect over the y-axis, which is really the x equals 0 line. It has to be that same distance from the line of reflection. So this is 1 unit from the line of reflection. It has to be 1 unit on the other side then. It's the image. The image has that same distance. So 1 unit from the line of reflection is at negative 1 on the x-axis. So that means this point is negative 1 comma 6. We look at the line of reflection and how far are we from that line of reflection. We flip it over the line of reflection and making sure it's the same distance away from it. The last one is a rotate. Now this one has to have what line we're reflecting over. When you reflect, you have to know what line you're reflecting over. When you rotate, there are several things that are needed. Where are we rotating from? We're rotating about the origin. So about the origin is our axis of rotation. We're doing it in a counterclockwise motion. So that's going that way, the opposite way a clock would normally go. And then we are rotating it 90 degrees, which is a quarter circle. So think about as if I did a little trick, if I jumped a half spin is called a 180. If I do a full spin is called a 360. So a 90 is half of a 180. So that's a quarter spin, half. Okay? So let's go ahead. Now with this one, it's really tricky. There's almost no easy way to do it. I have the graph just to make sure I land in the correct quadrant. That's basically the best we can do with the graph. So this is -5, -9. So this is my x, -x, y, -y. So -5 for my x, -9 for my y. 1, 2, 3, 4. 1, 2, 3, 4, 5 on the x in the negative direction. 1, 2, 3, 4, 5, 6, 7, 8, 9 in the negative y direction. So here's my point. And it's going to rotate counterclockwise. So the way a clock would usually tick, it would usually tick this direction. So I'm not going this direction, I'm going to go this direction. So we're going that way. That's the counterclockwise direction. So if I do a quarter turn around the origin, that means I'm going to land somewhere in quadrant 4. I'm going to land somewhere in quadrant 4. Now this is what I was kind of talking about in class, about having a math notebook. Now I had to go through the video, and sometimes I have to look this up each time. It's really tricky about how it's represented algebraically. So I had to write it all down in my math, like little note cheat sheet part. So at 90-degree counterclockwise about the origin. Counterclockwise, 90 degrees means the x and the y flip spaces and the y changes sign. So I always like writing it out. So I'll just write it out right here. So for this one, it goes x comma y turns into -y comma x. So that's the relationship that I'm trying to show here. So this one's -5 comma -9. All right, I flip the spots. So the x is -5. It's now in this spot. So there's the -5. It's now in the y spot. And then the -9, the y, goes into the x spot, but it has a sign change. So that means that's what you should have got. So this is my x, this is my y. Let's check to see if it's in quadrant 4. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 5. 1, 2, 3, 4, 5. So if it gets rotated that way, that's where it'll land. That's the point 9 comma -5. It's almost impossible to do it visually. You have to have your little cheat sheet with the little numbers that are kind of represented that way. If you're forced to memorize them, my advice would be to do it graphically so you can kind of get an idea, and then usually it's about switching numbers and switching signs.